In this video, I want to answer the question, what is a user story map? And how do we create one? A user story map allows users, developers and other stakeholders to visualize a whole product and its development process. It breaks down the work that we require to create the whole product into individual chunks called user stories. Or, to put it another way, it organizes your user stories into a logical sequence that creates a model for the whole product or service that you're building. User story mapping is a visual method used in agile software development that allows users and development teams to create a model of the product they're creating in terms of its functionality. It organizes user stories along with a short description of their functionality into a visual representation of the user journey through the product or service. Each user story represents a different capability, and the story map helps us to prioritize among those different capabilities. So, a user story map allows the team to describe all of the product's potential capabilities without losing sight of the big picture of how they all fit together. User story maps are usually presented like this. At the top, the themes or user activities represent the highest level of the things that users will need to do. Below these are the key steps in the process flow through the product or the service, arranged in a horizontal row. These are the major tasks that the user will need to perform, arranged in the sequence in which they'll need to perform them. In the language of user stories, these are big stories that we call epics. The sequence of epics is sometimes called the walking skeleton, and it represents a summary of the entire product, the flow of the process through it. Now, an epic is too much work to achieve in a single iteration or sprint or even release. So, epics are broken down into smaller user stories represented below their epic. These put the flesh onto the walking skeleton. Down the vertical axis, we sequence these user stories in the order of the priority that they have for us, and therefore the sequence in which we'll develop them. Those nearer the top we'll develop first, and those at the bottom we'll develop last, if at all. The priority can represent how fundamental they are, how much value they give, how complex they will be to develop, or how sophisticated the development methods and processes are likely to be when we come to develop them. So, why do we need user story maps? Well, user story maps help users and developers share a complete understanding of the whole user experience. But as well as being a communication tool, critically they provide two other things. They are a tool to help prioritize features and functionality, and they are also a way to stop us trying to prioritize purely on the basis of value delivered, which can of course lead to us delivering high value items, but not the user stories on which they are dependent, meaning that we end up with a product that doesn't work. They allow us to see the fundamental functionality on which other capabilities depend, and therefore to prioritize them and build them first. So if that's why we need them, what are the other benefits we get from using user story maps? The first is communication and alignment. User story maps are clear, they're unambiguous, and critically, they're available to everyone. They can create a shared understanding at many different levels of detail at the same time. Number two is status reporting. Once we have a story map, we can use labels, stickers, or simply writing on the information to show the progress against each user story in the story map. This creates a very simple visual representation of status or progress. Number three, they're a visual aid. They don't just aid communication, they also help with thinking, planning, problem solving, prioritization, and decision making. Number 4 is about product backlog. The prioritization process, working with the story map, supports the creation and grooming of your product backlog. And of course, it also helps to determine what our priorities are for drawdown to the next iteration or sprint. Finally, number 5 is dependencies. By representing user stories as a flow, a sequence of activities, it enables us to understand the dependencies, how one user story is dependent upon the capabilities of another to make it work. And by highlighting dependencies, story maps are also an important part of risk management. With all this goodness, you may be wondering, where do story maps come from? The idea for user story maps originated with Jeff Patton, who wrote an article but didn't name them user story maps in 2005. The article was called "It's All in How You Slice It," and I'll put a link in the description. Patton continued developing this idea, and in 2008, he illustrated it in detail on his blog in an article called "The New User Story Backlog is a Map." I'll link to that too. Finally, in 2014, he wrote the inevitable book, along with Peter Economy. The book is called User Story Mapping: Discover the Whole Story, Build the Right Product, and yes, you guessed it, link in the description. So, I bet you're now thinking, how do I create a user story map? Well, let me take you through the basic steps. First, you need to gather a team. Get together some of your users, developers, user experience experts, design experts, and any other stakeholders who have an input into creating your story map. Then, follow a simple process based on these 7 steps. Step 1. Establish the product. This first step is simple. Just establish what your users need to be able to do and why. Step 2. Define the product outline. Start by identifying the key steps in the product or service that you'll be creating. This, of course, will form the walking skeleton of epics. Each epic will be a heading for the story map you're creating. You may also want to group these epics into themes. Now, arrange them horizontally across the top of your map. You can do this in person using sticky notes and a board, or you can do it remotely using collaboration tools. The whole team should work together on creating the map, and it's often useful to assign a facilitator to make sure that everybody gets their say and everybody's opinions are listened to and respected before the team makes a decision about how to place a user story. Step 3. Develop the capabilities under each of the epics. Under each epic, place the user stories that make it up. Now, these user stories don't have to be fully developed or prioritized at this stage. That can come later. Frame your user stories in terms of what the user will be doing at this step. This is a better way to frame user stories than a description of how the product is performing or what the technology is doing. In my video on epics and user stories, I gave a very simple model for describing a user story. As a type of user, I want to be able to action so that benefit. Step 4. Prioritize user stories. Keep growing your story map until you have enough user stories on it to start to prioritize them and to identify dependencies among the user stories. Now you can start to prioritize your user stories in the vertical dimension. Under each epic, sort out your user stories with the highest priority ones at the top, all the way down to the lowest priority user stories at the bottom. Once you've done this, you can divide across this vertical dimension to create a number of releases, with some user stories under each epic in each release, and the first release, the highest priority, being the minimum viable product, or MVP. If you're not familiar with the term minimum viable product, then take a look at our video. Step 5 is to scrutinize your work. Now you have a good visualization of the whole product development process, it's time to look at it with care to identify things like dependencies, bottlenecks, gaps, overlaps, missing information, and alternative options. Each of these is a risk, so finding them before you start any development work will de-risk your project massively. It will avoid the waste of potential rework and possibly improve the usability and quality of the final product that you deliver. Step 6. Plan releases and sprints or iterations. Now's the time to turn your story map into a work plan. With user stories prioritized top-down, you can immediately see those user stories which will deliver either foundational capabilities or the high-value capabilities that you'll want to develop early. Group these into product releases and then into provisional iterations or sprints. Step 7. Publish your user story map. Finally, you're ready to share your user story map with the full development team and a wider range of stakeholders. But remember, user story mapping, like every agile process, is iterative. Once you've created it, the team needs to maintain it and develop it to accommodate changing information and new understanding of the work you're doing. Your user story map needs to be a living document that you can use to track progress, that you can modify and add to and take away from. It's a tool that you can use to help you groom your product backlog and to determine the drawdowns that you'll make to create each iteration or sprint backlog as you move through the product development process. Finally, I'd like to end with a few tips about using user story maps. First, you need to be absolutely clear about who your users and customers are. And of course, once you know who they are, you need to engage them in the story mapping process. Second, you need to balance the amount of detail you put into your story map to ensure that you have enough detail to work from, but not so much detail that it hides the big picture and makes it hard for people to understand the whole process. What you don't want is for the story to be lost in the detail and for your customers or stakeholders to become confused. Remember that many of your stakeholders are likely to be less familiar with a user story map than you are. Next, you need to think about the scale of your user story map. If you try to illustrate a massive product on a single user story map, then you might find it difficult to get the level of detail just right. So, break your user story map into smaller maps representing manageable chunks of the product to make it much easier to get the level of detail on each one correct. Next, think about the level of formality and technicality in the way that you describe the elements of your user story map. The basic rule is to keep the style simple and the language plain so that every user, every stakeholder, every customer can easily understand your story map. If you need to use jargon or acronyms, make sure that you explain what each term means. Keep the technical development details off your user story map, and if you need to run a parallel document to explain greater detail parts of the story map for the developers or particular customers, then do that rather than cramming all the information into one document. You also need to be really clear about the problem that the user story map is trying to solve for your customers or users. Keep checking to make sure the story map leads to the right goal. Otherwise, you could potentially end up developing an excellent product which doesn't meet the user's needs. And finally, in determining the tools you use to create your user story map, think about the efficiency of the process, because all of the user stories on your map will need to end up eventually in your product backlog. This may lead to you feeling like you're going to have to do the same work twice or repeat work. So, consider using a software tool that can integrate user story maps, product backlogs, and sprint backlogs so that you can do the work once and represent the information in many different ways. User story maps are a fantastic tool. In many ways, we can think of it as an alternative to the work breakdown structure that project managers use in predictive projects. But my feeling is that for many predictive projects, user story maps could be a great tool for project management teams to use to help their clients, their customers, their sponsors to understand their project better. And maybe even the project teams will find them a useful way to understand and articulate the project. My dictionary tells me that a backlog is an accumulation of uncompleted work or matters that need to be dealt with. But in this video, I want to answer the questions: what is a product backlog and what is a sprint backlog? A backlog is a list of requirements, usually arranged in priority order and usually expressed in terms of stories. For more on that, see our video, What are Epics, User Stories and Story Points. The project team will maintain a product backlog of user requirements for the product under development, and as new requirements emerge, the team will add these to the backlog. Sometimes the product owner will arrange these user stories within the backlog into a logical sequence to form a product roadmap that sets out how the different stories will be delivered by the team. However, the backlog does not belong exclusively to the product owner. It needs to be fully accessible to the whole project team, because it is a single source of truth on what the user requirements are that the team will need to develop. Typical backlogs consist of features that the team needs to create. However, they can also include other things, such as bugs to fix, changes to make, research to carry out, or infrastructure or assets to build. We're going to look at how backlogs work in 3 of the common Agile methodologies: Scrum, Kanban, and Scaled Agile Framework. Let's start with Scrum. At the start of each sprint, the Scrum team will draw down a number of features or stories from the product backlog to work on during the coming sprint. This then is known as the sprint backlog, and it is a subset of the entire product backlog. Usually, the sprint backlog will also contain a statement of the sprint goal, which the sprint team develop and articulate during the sprint planning stage. So, the sprint backlog articulates the work that the development team need to carry out during the sprint to achieve the sprint goal. However, the sprint backlog does need to remain under constant review during the sprint, and it is updated as needed, typically at the daily Scrum meeting. It's important to note that not all of the feature requests or user stories in the product backlog will get developed. Over the course of time, the team may learn that some of those requirements are of marginal value. And as they move from sprint to sprint, there may come a time where the remaining feature requests and user stories do not have enough value to justify the cost and the effort of additional sprints. Kanban is more usually used for continuous delivery rather than development. As a result, the team draws down items from the product backlog continuously, and they do so in such a way that the work under review and being undertaken at the time never exceed the work in progress limits set for the team. And those work in progress limits are dictated by the team's capacity to get work done. Scaled Agile Framework has a series of different backlogs at different sizes, rather than a single product backlog. Each of these backlogs contains different amounts of detail. The portfolio backlog contains information about the different initiatives that the organisation is working on, and they are sometimes referred to as epics. The solution backlog contains high-level backlog items that will form different aspects of the solution, and they're often known as either capabilities or enablers. The program backlog contains lower-level backlog items that also form different aspects of the solution. They are often known as features. Finally, the team backlog contains the items, the user stories, that the team is working on, and is therefore equivalent to the sprint backlog. So how is a product backlog maintained? The product backlog and the roadmap that emerges from it are maintained under constant review throughout the program. As new feature requirements emerge or users identify new ideas, the backlog grows and the roadmap evolves. It's the responsibility of product owners to review the backlog constantly, taking into account those new ideas from the users, but also feedback from the development team. This regular review of the backlog is sometimes known as backlog refinement or backlog grooming. As the backlog grows larger, it becomes increasingly important that product owners impose some order on it, perhaps labelling some items as near-term, medium-term and long-term features. Near-term items on the backlog will have a lot more detail attached to them, including a full user story and possibly some substantial estimates of how much time it will take to develop the feature. The team may also develop a definition of ready, which sets out the conditions under which the team will consider a backlog item ready to move to development and therefore to the sprint backlog or the team backlog in Scaled Agile Framework. Long-term items on the backlog, however, need only have the briefest and roughest of information. So, a backlog is an accumulation of work that an Agile team needs to carry out. The concept is very useful in all forms of project management because, of course, all forms of project management are really some form of hybrid project management. So, whatever kind of project you're doing, think about how you can use the concept of a backlog to bring order to the chaos of requirements from your different stakeholders. In this video, I want to answer the question, what is T-shirt sizing? T-shirt sizing is a simple and popular way to estimate the relative sizes of different pieces of work, and it is widely used in the Agile software development community. There, T-shirt sizing is usually applied to user stories, and we have a video that will answer the question, what are user stories? And also epics and story points. T-shirt sizing estimates are rough and ready. They're designed only to give a first indication of the approximate amount of work required to deliver a user story. They are less precise than full estimates, or even than another Agile estimation practice, planning poker, about which we also have a video. Typically, we assign a T-shirt size to each item of work. Different users, different environments, different teams have different ideas about what T-shirt sizes to use and what scale of work they represent. I would recommend that you limit yourself to around about 4 or 5 different T-shirt sizes, but some examples of the kind of T-shirt sizes people use are these: extra small, small, medium, large, extra large, or even extra, extra large. In general, the more different sizes you use, the harder it is to get real consistency in the way that people within the team will interpret those sizes in terms of the amount of work they represent. That's why I believe it's sensible to limit the number of sizes that you use. Small, medium and large are of course the core sizes, and you need to think very carefully about whether you add one or two additional sizes onto one or both ends of that spectrum. It's good practice to start the process of t-shirt sizing to work through a number of type examples, to talk through a number of specific examples that might match the small, medium or large categories, for example. That way the whole team can get a common sense of what kind of activity is a small or a medium or a large activity. There are different ways we can interpret the sizes in terms of quantity of work. Perhaps the commonest way is to use Fibonacci numbers as the levels in much the same way as teams do with planning poker. To illustrate, let's use the full spectrum of 6 different sizes, in which case we might allocate 1 unit of work to extra small, 2 to small, 3 to medium, 5 to large, 8 to extra large, and 13 to XXL. An alternative might be to use an exponential scale: 1, 2, 4, 8, 16, 32, and 64. That would be suitable if you have a very wide range of different scales of work that you need to plan for. The other approach is to use the t-shirt sizes to indicate the number of sprints or iterations the team expects to need to use to develop the full functionality of the user story, or indeed epic. In this case, an extra small task might be done in less than 1 iteration, whereas a small task may take a full iteration, and a medium task may take 2, maybe 3 or even 4 iterations to achieve. A large task might take 4 to 8 iterations, and an extra large task more than 8 iterations. You'll find lots of different statements of the process for t-shirt size estimation. Let me give you my simple 6-step process that you can adapt to your own preference. First, agree the sizes that you're going to use and their definitions. And when you've done that, you can make a number of t-shirt size cards. And why not make it fun by cutting out the cards into t-shirt shapes? It might also be fun to use different colours. However, be aware that some people are colourblind, and therefore relying on colour alone to indicate the t-shirt size would be foolish. Second, the product owner will describe a user story as clearly as they can. The development team will then ask the product owner as many questions as they need to get a full understanding of the user story and its requirements. From this, each developer will give the user story a t-shirt sized based on their understanding of the requirement and the amount of work it will take. Critically, all of the developers will raise their cards simultaneously so that we get genuine independence of thought, rather than some developers shifting their opinion based on what they think other people might be thinking. Next, the development team will discuss any differences in perception, particularly if one individual sees the world very differently to others. The team will ask the product owner as many questions as they need to understand further, because often the differences can arise because different developers interpret what the product owner has said in a different way. The team will then repeat steps 3 to 5 as many times as they need to till they reach consensus, and then they can move on to the next user story. So why is t-shirt sizing so popular? Well, there are 3 main benefits as I see it. First, forcing the estimates into a small number of clearly defined categories is informal, it's simple, and it's quick. And it doesn't overburden the team with a level of precision which they might mistake for accuracy. Second, it's very effective for working through an entire backlog to get a sense of which user stories in the backlog are of similar size and which ones are very different. This allows us to cluster user stories into groups that represent similar sized pieces of work in a process that is known as affinity mapping. And thirdly, it's popular because it's fun. T-shirt sizing is an informal and fun way of estimating that takes the drudge out of the process. In this video, I want to answer the question, what is planning poker? Planning poker is a tool used to estimate how long activities will take in a project environment. It derives from the Agile world. It's a tool used in Scrum, but it's a tool that I believe can be used effectively and to great benefit in all sorts of projects. You can use planning poker to estimate durations for a predictive, plan-driven project. Therefore, as a valuable tool, it's something all project managers need to know about, not just Scrum Masters and members of Agile project teams. Planning poker starts with getting together all the people who are going to do the work. It works on a simple assumption, and I believe the correct assumption, that a diverse group of people working together to make an estimate will produce better results, more accurate estimates if you like, than individuals, no matter how expert they are. In fact, experts tend to be blinded by their expertise and blinkered to think in one direction only. In a diverse team, well, they will approach the problem from multiple angles. The principle is simple. We capture each of the requirements that we have, the user stories in Scrum language, on individual cards. And then each member of the team will make an independent estimate of how long they think that activity will take. The team then compares estimates, rethinks its approach, and we continue until we get an answer. If you think the task will take a lot of effort, then you give it a high number in your estimate, and if you think it won't take very much, then you give it a low estimate. Different answers from different people are the basis for a discussion and for deepened understanding among the whole team. The outcome of a round of planning poker needs to be consensus. The whole team needs to agree on one estimate. The planning poker process is based on the Delphi technique, which has been used for many years and was developed by the Rand Corporation. Let's go through a simple 10-step planning poker process so that you can understand how it works. Step 1, the product owner, the person who's responsible for delivery, will read out a user story, a requirement that the users or the clients have. In step 2, the whole group will discuss the story. They will ask questions, understand the technical nature, inquire into the potential risks, how novel the idea is, or how conventional it might be. When the group has heard from every team member, in step 3, each team member independently picks one planning poker card that represents their assessment of how long the task will take. And I should say that the numbers on the planning poker cards are not 1, 2, 3, 4, 5, 6. They get bigger and bigger, but with larger gaps, and they tend to follow roughly the Fibonacci sequence. This is because the longer the estimate is, the larger the task is, then the less precise we can be, and therefore it makes sense to use broader and broader estimates. Different planning poker sets have different specific numbers on them, but they all do tend to be based on the Fibonacci sequence. Each number is approximately as big as the two previous numbers added together, although often we use rounded numbers. When the team members have selected their estimate, step 4 is for each of them to place their estimate face down in front of them. And it's only when everyone has done that at step 5, each team member turns over their card and shows them to the team. If there's already consensus, if everybody plays the same card, we're done. However, that rarely happens on the first round. Sometimes some people will have a significantly larger or a significantly smaller estimate than most of the group. Those are the people we need to hear from. So at step 6, people who have played outlier cards with extreme estimates in one direction or the other will explain their reasoning. And the team will be able to ask them questions to understand their thinking. When they explain their thinking and everyone is satisfied that they've understood it, then step 7 is to repeat the secret voting process. If that doesn't produce consensus, then I'm going to call this step 8. You continue repeating the process again and again until you reach consensus. I'll tell you in a minute what you do if you don't quite reach consensus. Step 9 is when consensus is reached. Then the product owner will record the consensus estimate on the user story card, and you'll move on to the next story card and work on the next estimate. Finally, step 10, we take all the estimates and use that as the basis for planning the next stage in the project. Now, there are reasons why we often get wide ranges and extreme outliers or a difficulty in finding consensus, but typically it's for one of two reasons. Either on the one hand, it's a lack of detailed understanding and definition of what the user requirement is, and on the other, it's a lack of understanding of the technical nature behind achieving that requirement. One option, therefore, is to resolve the uncertainty by taking a time out, asking people to research either a clearer definition or gaining a better understanding of the technical requirements, and then to return to another round of planning poker at a later date. If you can't resolve the uncertainty, and believe me, quite often what happens is that a holdout will take time, but eventually be drawn into consensus. But if you really can't resolve the uncertainty, then you know something very important, which is that there is a wide range of possible outcomes in terms of the duration of the task, and therefore the range is what you need to record as your estimate. So, planning poker is a simple tool for estimating that harnesses the wisdom of a group. It's widely used in projects that follow the Scrum approach, but I believe you can be using planning poker in any sort of project, including traditional waterfall planning predictive projects. In this video, I want to answer the question, what are Burndown charts? And also, what are Burnup charts? And also, what is velocity? Quite simply, Burndown charts and Burnup charts are a way to measure progress. A Burndown chart plots outstanding work against time, whilst a Burnup chart plots completed work against time. Let's start with the Burndown chart. On a Burndown chart, as you make progress, as work is completed, then the amount of work remaining diminishes, which gives us the characteristic downward slope of the Burndown chart, which gives it its name. If, on the other hand, we plot work completed against time, then guess what? The work completed increases, and therefore the Burnup chart gives us a characteristic upward slope. It seems to me that in Agile projects, Burndown charts tend to be more often used to measure progress on a single iteration or sprint. On the other hand, Burnup charts are more often used to summarize progress on the whole project, and therefore time is often measured in units of an iteration or a sprint. As I just suggested, Burn charts are most often used in support of Agile, project management methodologies. The time axis can either represent days on an individual iteration or sprint, or can represent a longer period of time and is therefore likely to be measured in units of an iteration or a sprint. The work units are likely to be either estimated hours of work or numbers of story points. We can get an idea of our progress against schedule if, at the start of a cycle, we plot an ideal work curve, and then if we plot work completed onto the burn chart as we go, we can see how the two compare. Clearly, when we plot the ideal or planned burn curve initially, if we use hours as our estimate for the amount of work, then we would expect to see a straight line. When we use story points, and assuming all of our story points are of the same size, then again, we would expect to see either a straight line or more likely a jagged line that follows the path of a straight line. But of course, we may not complete a whole story point or finish a story point within a single day. If, when we plot our actual burn down against our ideal or planned burn down rate, we find that the actual burn down curve is above the ideal line, then we know that the project is lagging and the team has to work hard to find a way to get back on schedule. If, on the other hand, actual progress lies below the ideal line, then we know that the team is ahead of schedule. This means that it may finish its backlog before the end of the cycle. This may mean that they choose to go to the product owner to draw down another user story into the current backlog so that they don't waste time during the cycle. Velocity describes the rate at which work is done and deliverables are produced. Note that velocity does not measure efficiency. This is because there is no way to calculate an ideal or baseline efficiency level in a project environment where we don't have long-term data. Rather, the purpose of measuring velocity is all about estimating and being able to calculate how long we expect future story points to take us to deliver. As we build up data about our velocity, we can better estimate the number of story points that we need to bring into a cycle so that we can finish it in the cycle time. We calculate velocity as the work completed divided by the time elapsed. Typically, velocity is calculated over the time frame of a single iteration, cycle, or sprint. As I said, we use velocity for planning future work. The velocity from previous cycles is the best indicator we have about the rate at which the team will be able to do work in future iterations. This allows the team to estimate how many story points to draw down into the next sprint backlog. The most reliable calculation of velocity, of course, averages the velocity calculations from a number of cycles and iterations. So as the project progresses, your estimate of velocity is likely to improve. However, it's worth considering that as you go on, it may be appropriate to remove from your averaging process the very earliest cycles or sprints, because at the start of the project, the team is learning how to work together. As it improves its methods and processes and ways of working through its retrospectives, then its velocity should naturally increase to reach an ideal level. In the Scrum methodology, velocity, measured as story points per sprint, is the single most important measure that we have. We have videos on Scrum, and we also have videos talking about how to estimate using planning poker and t-shirt sizing methodologies. I'll put links in the description. I want to end with an important point. Because you cannot use velocity as a measure of efficiency, You also must not use it as a performance measure to assess the performance of your team. And you certainly should not be using velocity as a KPI for the team to perform against. In this video, I want to answer the question, what is a sprint retrospective? In the Scrum framework, a sprint retrospective is the last step in a sprint. Its purpose is to identify and plan ways to improve the effectiveness of the team and how it works together. A sprint retrospective gives the team an opportunity to reflect on the way that they've worked, to share insights and ideas, and to identify areas of improvement that they can carry forward to the next sprint. So, who should attend a sprint retrospective? Well, first, the Scrum Master. Second, the Product Owner. And thirdly, the development team members. The development team is everyone who has a role in designing, developing, and testing the product. The sprint retrospective may also include a small number of other relevant stakeholders. However, stakeholders, users, and managers who aren't a direct part of the development team don't usually attend a sprint retrospective unless they are specifically invited. Instead, they will attend a sprint review meeting. This is where the Scrum team will demonstrate what they have achieved during the sprint. This will often include product demonstration. So, a sprint retrospective is an opportunity for the team to focus on its own processes, and a sprint review is an opportunity for the team to demonstrate the products that it's created. A sprint retrospective is usually facilitated by the Scrum Master, although the team can nominate another individual to facilitate its retrospective. Typically, a sprint retrospective review lasts for about 45 minutes for a 1-week sprint, but then is longer for a 2 or a 3 or a 4-week sprint. Probably it's a maximum of about 3 hours, which would be for a whole month sprint. The facilitator, usually the Scrum Master, will encourage the team to consider how the last sprint went. In particular, they'll be looking at how its processes and practices worked rather than the outcomes it achieved. The team will look at things like individuals and the interactions between them, the team's processes, procedures and ways of working, its tools and methodologies, the definition of done that it adopted, and any assumptions that seem to have led the team astray. What's on the agenda and the questions the team will ask and answer will often vary according to the domain and also to the culture of the team and the style of the Scrum Master. However, there are a number of questions that are typical and will give you a flavour of the sort of questions that a sprint retrospective will ask, address, and answer. What went well during this sprint? What went wrong? What could be improved? What problems did we encounter? And how were, or weren't, those problems resolved? What did we learn? What will the team commit to doing in the next sprint? The team will look for ways to improve its workflow in the next sprint. This is fundamentally the meaning of adaptive project management. The team adapts to its situation and learns from its experiences. They'll select the most helpful changes that they can make and prioritise those changes that will deliver the greatest impact. The suggestions from a sprint retrospective may even be added to the sprint backlog and drawn down in subsequent sprints. In many ways, a sprint retrospective is a new take on an old practice, the lessons learned review. The important thing to note is that it's short, sharp and focused. It happens with strict regularity at the end of every sprint, and its focus is entirely on the processes and the ways that the team works together, rather than the outputs or the outcomes it creates. Please do give a thumbs up if you like this video. There'll be loads more great project management content for you, so please do subscribe to the channel and hit the bell so you don't miss any of it. And I look forward to seeing you in the next video.